Does this series converge or diverge? As with any series, what I'll go ahead and do is I'll apply the divergence test, see if this series diverges, or if it's inconclusive, try another test. Looking at the general term, if we let n approach infinity, what I would notice is that the factorial would grow at a faster growth rate than an exponential or a polynomial term, which makes me think that if I were to take the limit of this, it would push off to infinity. And if I'm going to infinity with my limit, that tells me that this series would diverge according to the divergence test. Now let's say we know our growth rates and we're comfortable with the fact that factorials grow faster than exponentials and they grow faster than polynomials. But we don't know if a factorial grows faster with the combination of these two things, right? So if we have these now combined together, their growth power might be affected, who knows? So instead, why don't we try a different test? I'm going to go ahead and try the ratio test because of the fact that I'm working with not only factorials, but also exponential terms. The ratio test is great for these types of terms. We start out by writing the limit as n approaches infinity of a to the n plus 1 divided by a to the n, where here I just did a keep change flip so that I didn't have to have a complex fraction, I could just multiply across. And then I'll do a bit of rearranging where I put the factorial stacked on top of each other, then I put the polynomial term stacked, and then the exponential stacked. So what do we end up with? Well, n plus 1 factorial over n factorial simplifies to n plus 1. N over n plus 1 stays as is. And 6 to the n divided by 6 to the n plus 1 simplifies to 1 over 6. Simplifying the n plus 1 in the numerator and denominator, we end up with the limit as n approaches infinity of absolute value n over 6. This limit goes towards infinity, which is greater than 1, and therefore we know that our series is going to diverge according to the ratio test.